Tomorrow, Mr. Hall's second period class. Unit 5, Part B, practice test, absolute value, equations, and inequalities.
What a legend!
Okay, so let's celebrate what we know for the test tomorrow and figure out what we need to study and practice tonight.
All right.
Number 1,
Yeah.
we're looking for solutions. Whenever I have an absolute value equation and I have an equal sign, I almost always will have 2 answers. The process we learn to solving these is to first isolate the absolute value by applying properties of equality. So first we added 6 to both sides. Grayson's going to be quiet, pay attention. Then we divided by 2, and we got the absolute value of n equals 2.
Oh. I divided.
Once we do that,
I accidentally divided before I added.
What?
you might want to think before you mention those mistakes that you're making. All right, n equals 2 or n equals -2. That one was done because we didn't have anything to solve. So those are my 2 answers. Now, how do I know those are right? Well, I could check, is 10 times the absolute value of 2 minus 6 14? Yes, 20 minus 6 is 14. Is 10 times the absolute value of -2 minus 6 equal to 14? And the answer is yes. It also, absolute value of -2 is 2, times 10 is 20 minus 6 is 14. Number 2 is very similar. I'd subtract 10 from both sides, except here is where I have to notice, wait a minute, I can't take the absolute value of a number and get a negative, so there's no solution. Number 3, I had to add 1 to both sides, so this takes us back to our very first unit of the year, when you guys had to apply properties of equality to solve equations. Good review for some of you. And then I'd multiply by 5 to undo that, inverse operations, and I get absolute value of p equals 5. Once I have isolated my absolute value, I write 2 equations, p equals 5, or p equals -5, and there's my answers. So these ones were not very difficult because once we isolated our absolute value, we just got our 2 answers, and plus -5 is fine. If we check those, they would work. Number 3, you have to do a little bit differently. We start out right away, since our absolute value is already isolated, we go ahead and write 2 equations, one being what it is, just dropping the absolute value, and the other one being left stays the same, but because of the absolute value, we need to consider the negative answer on the right. On this one, we subtract 1/2 from both sides, and we get 4.5, so x is 4.5 or 4.5. Over here, we'd subtract 1/2 from both sides. -5 plus a -1/2 is -5.5. So those are your 2 answers there. So you can't use the plus or minus there if they're different numbers, right? Great. Okay, number 5. We learned when we were solving absolute value inequalities that if it starts out as greater than or equal to, it's going to be an OR. That was in our toolkit.
No way.
Okay, so the first equation, after we isolate the absolute value, which is done for us here, we would write 2 equations. 9x is greater than or equal to 27, or 9x is, and then we reverse the inequality and change the sign. Okay, that's what your toolkit's for. That's silly, right? Because those are the only things we learned that were new. And then we go ahead and solve these separately and graph. Here we get x is greater than or equal to 3. And then over here, we divide by 9 and get x is less than or equal to -3, and it is an OR. So I'm going to go ahead and graph my first one. X is greater than or equal to 3, so we need -3, -2, -1, 0, 1, 2, 3. Please label your number lines, at least the final one. X is greater than or equal to 3, looks like this. X is less than or equal to -3, looks like this. If it's an OR, I combine, it has to be on one or the other to be part of the final graph. So I go like that, and that is my final answer. So in order for this to be true, any value -3 or less, or +3 or more, will make that a true inequality. Okay, number 6. Same dealio here. my absolute value has already been isolated, so because it starts out as less than or equal, it's going to be an and. So I write the first one as is, and I write the second one by reversing the inequality and changing the sign to the right. Then I go ahead and solve. On this one, I divide by a -4. Don't forget that was the only kind of tricky thing we learned in the last unit, or the beginning of this unit, was to reverse the inequality when you multiply or divide by a negative. And over here, we do the same thing. We divide by a negative and get, that would be less than or equal, right? Correct. And we get 10. So if since I can't fit all that on here, I'm just going to go by 2's, -8, -6, -4, -2, 0, 2, 4, 6, 8, 10. Okay, this is an and. Where is x greater than or equal to 10 and less than or equal to, -10, sorry, and less than or equal to 10? Where is it both? Places.
In between.
At -10, at 10, and everywhere in between. That's where they're both graphed. That's what we're looking for when we're looking for an and.
Why'd you put no solution?
I didn't.
Oh, I forgot.
Okay. Okay. Number 7. Again, it's going to be an or, so d minus 3 is greater than or equal to 2, or d minus 3 is less than or equal to -2. Here we add 3, and we get d is greater than or equal to 5. And that would, well, let's figure out what our numbers are first. Here we'd add 3 and get d is less than or equal to 1. So then we have to figure out what our main numbers are here, and they're 1 and 5. So 0, 1, 2, 3, 4, 5. So if I go d is greater than or equal to 5, d is less than or equal to 1. And the question is, it's an or, so where is one or the other graph? And it's either everywhere out here or everywhere out there. So that's my final answer. That's my graph.
So it's everywhere but not between 1 and 5. There's infinite numbers between 1 and 5. You know that?
Yes. Okay. Next one. It's going to be an and because it starts out as less than or equal to. So d minus 4 is less than or equal to 1, and d minus 4 is greater than or equal to -1. Notice that we do the same thing every time, pretty much, pretty close. D is less than or equal to 5, and add 4, D is greater than or equal to 3. Okay, so I need 3. So if I have 0, 1, 2, 3, 4, 5, and then I go, D is greater than or equal to 3, D is less than or equal to 5, where are they both graphed? So every one of those is typical ands or ors. Either one out if it's an or, in the middle if it's an and. Okay, just to follow up to what we just finished. Okay, so this was a good question. Below are the graphs y equals x, absolute value of x, and then absolute value of x plus 10. We learned that this moves the parent function up 10 units on the y-axis. So are these two graphs the same? No. Do the graphs have the same y-intercept? No. Do the graphs have the same shape? Yes. Do they have a y-intercept of 0 and 10? Yes, but this doesn't say y-intercept. A lot of you actually didn't read closely enough and recognize that this one says x. This one says y, and therefore this is the right answer, D.
Yeah.
Number 10. Okay, so we learned that this absolute value outside, or the number outside, just moves the parent function down. So we learned that this is just going to look just like our normal parent function, which I'll graph real quickly, and that's not the one I want, so I'm going to undo that. Going to get my array here. There it is. So I'm going to make the parent function. It's up 1 over 1, right? So it has a slope of 1. So I'm going to put that there. And, well, yeah, I'm going to graph the parent function. Good, Brandon. I'm going to graph the parent function first, and then I'm going to copy and paste it because we're going to use that a bunch. So I'm going to show you what the parent function looks like, okay? And then I'm going to group it and show that we're going to use it a lot today. Okay, so we are going to go up and lock this page in place and try that again. Okay, so now we're going to go ahead and group these because this is our parent function. It's the one we're going to see a lot. So we're going to group it and we're going to copy. Okay, so in this case, this one would be at -2.
Yep.
It'd be the exact same function, up 1 over 1, or up 1, back 1, and then right there. I think you guys pretty much got those, the ones that were easy. Now, what does the negative do on this problem?
Let's go down.
Good, it flips it upside down. So if I go ahead and phase,
Oh, yeah.
okay, and then if I go ahead, and this is what's cool about the smartboard, is I can actually do a flip, which is a transformation, okay, and then it starts at 5 because the plus 5 out here, so that means I go up 5 on the y-axis. There it is, right? Now, did that one have a table next to it? Okay.
No, 12 is
11 did not? Okay, so number 12, you do need to fill out a table. I need to be assured that you can fill out a table. So, well, let's find out how well you did then. So, table, and we want 4 columns. Oh, we can go 5 columns, or actually, I think I had 6 on yours, didn't
No,
I?
You have 4 columns to the side and 6 down.
Those are columns.
Oh,
Oh, you're right. So it's 4 columns, 6 rows.
4 rows and 6 columns. No, the other way around.
No, that's not it. No, yes.
4 columns, 6 rows.
Okay, remember, these are columns up and down, these are rows. Okay, so we have input, the function, output, and then our ordered pair, right? So,
Just follow.
Eric, is this the one you wanted to give me the,
Yeah.
Okay.
2, 1, 0, -1, -2.
okay. So if I put in 2, I get 2 times the absolute value of 2 is 4, minus 3 is 1.
Oh, so I got that right. It's just in separate order.
2 times the absolute value of 1 is 2, minus 3 is -1.
I'm at 0, 1, -1, 2, -2.
If I put in 0, it doesn't matter. Remember, you guys get to pick your own, but you just have to make sure they're the right ones. 0 minus 3 is -3. 2 times -1, absolute value -1 is 1, times 2 is 2, minus 3 is -1. So you have to evaluate absolute value before you do the rest, right? It's like a grouping symbol, right? And then we have 2 times absolute value -2 minus 3.
Shut up. You speak like my dad.
Absolute value of -2 is 2, times 2 is 4, minus 3 is 1. Now if I graph these ordered pairs, I have 2, 1. I have 1, -1. Whoops, I put that in the wrong spot. 2, 1. 1, -1. I have 0, -3, which is my vertex. I have -1, -1. And I have -2, 1. Now if we look at our equation, y equals absolute value of x minus h plus k, remember, what's our vertex? Well, what is x, what are we subtracting from x here? 0,
0.
because it's x minus 0 is x, right? So according to this, my vertex would be 0, -3. And look, it was. Pretty cool, huh? Now, can I use my parent function here?
You can. You can.
Good, Brandon, it's twice as tall. It's twice as steep.
Narrow.
It's narrower. Narrower because the slope is 2 or -2. Narrower. So I said, kind of. Okay. So we're going to go like that, up 2 over 1. Ooh, there it is. Okay, but I needed to see that you understand how you get that. Okay? So if there's a table, you need to fill it out. Number 13. Okay, these are probably hopefully the easiest ones for you on the test. You know if it goes down, there's a -2 on the outside. You know if it goes up, there's a plus 6.5 on the outside. So make sure you get those right, because those are the gimmies. Okay, those get the easy ones right. Okay, now we learn that if it's inside, remember, if we're adding something on the inside the absolute value, it's going to move it the opposite direction that many units. And it's the parent function. So on this, how many units am I going to move it?
3.
What direction?
What?
Oh.
That was hard, right?
Yeah.
And the next one, I needed to make a table. Correct, Mundo?
Yeah.
Yep. So
Rainbow.
we're going to go ahead and make our table. I wish it would have saved that, but that's okay. All right, so let's go ahead and do our table again. We'll use Eric's. Well, actually, what is the vertex?
-5.
1.
1, 0. Very good, Brandon. How'd you know that?
Because it's opposite
Okay, so it's minus h, so in place of h we have 1, so that's an x-coordinate. So our vertex is 1, and then there is no k, so we could say it's 0, right? Because if we're not adding nothing, it's 0. So that is our vertex. Why is it helpful to have our vertex?
That's where you know where it'll change direction.
Very good. That's exactly right, Maggie. That's where we know it'll change direction. Okay? So that way I know that if my vertex is at 1, I want that to be my middle number, and I want to pick 2 on each side, right? I want to pick -1, 0, and 2, 3. And watch what happens when I do that. If I pick my vertex as my middle number input, okay, I know this one's going to be 1, 0. Okay? So I have -2 times the absolute value of -1 minus 1. So that's -2, absolute value is 2, times -2 is -4. Here, if I put in -2 times 0 minus 1, absolute value of -1 is 1, times -2 is -2. And when I plug in 1, I get -2 times 1 minus 1, which is -2 times 0. When I plug in 2, I get -2 times 2 minus 1 is 1, times -2 is -2. And lastly, when I plug in 3, I get 2 times -2 is -4. And see what I get for my inputs and outputs when I put my vertex in the middle. What does it look like?
0.
Look at the outputs. Aren't they mirror images of each other? Here's the middle.
Yeah.
-2, -4.
Yeah.
So that's where we get that
Minus
symmetry.
three.
Yep. So then we go ahead and graph those points as usual, and we get 1, 0, -1, -4. This one's going to be upside down because of that -2. We have 0, -2. We have 2, -2. And I can just tell by this that it's going to be 3, -4 without even looking at my table.
Oh, yeah.
Now I can go ahead and graph this. And it looks a little something like that. Whoops, that's not going to work. Try this again. And there it is. Okay. It wasn't supposed to go through that one there.
That's okay. We get the point. What the?
That's funky. Okay.
That's
This one also had a table, correct, Mundo?
No.
Okay, just look on your paper. You should be able to tell.
Got it. Had a table up front.
Good. I was a little concerned there for a minute.
Let's not.
Well, they're all the same, right? So here, inputs. Okay, what is, someone else tell me what the vertex is. Besides Brandon. Maggie. 3, -5. Way to go. So that's going to be my middle input, right?
I can give you mine.
Okay. Here's 1/2 times the absolute value of x minus 3 minus 5. What would be good, what kind of outputs do we want from our absolute value?
Just want one diagonal.
Multiples of 2, right? Would it be nice to have multiples of 2? Okay, so that's what I'm going to do. Just because I want you guys thinking this way. Check this out. Okay, if I plug in 2, am I going to get a fraction? Yes, because I'm going to multiply 1/2 times 1 and I'm going to get a fraction. So what if I picked 1? What if I picked 5? What if I picked -1 and I picked 7? So I picked multiples of 2. Check out what happens. This is really cool.
No way.
Wait. So I go 1/2 times the absolute value of -1 minus 3 minus 5. Some of you are goofing up here, so pay close attention. -1 plus a -3 is -4. Absolute value of -4 is 4. 4 times 1/2 is 2. 2 minus 5 is -3. 1/2 times 1 minus 3 is 1 minus 3 is -2. Absolute value of -2 is 2. 2 times 1/2 is 1. Minus 5 is -4. Okay? And then if I plug in 3, I get 1/2 times 3 minus 3, which is 0. So I get 0 times 1/2 minus 5 is -5. What am I going to get for this output here?
You're gonna get a
Negative 4. Because I picked my vertex as my middle, then I know it's going to be symmetrical. That's what happens always with an absolute value function. So if you had this much all the way through your vertex filled in, would I mark you off if you didn't do this little work box? No. Because you should be able to see the pattern by now if you pick the right inputs. So therefore, I can go negative 1, negative 3. I can go 1, negative 4. I can go 3, negative 5. Oops, put that in the wrong spot. My bad. 1, negative 4. 3, negative 5. And I can just tell from this where my next 2 points are going to go. Did it get wider or narrower?
Wider.
Wider. Good, Eric. Wider. Why did it get wider? Why did it get wider, guys?
Because it's left to more.
Good, because of this guy right there.
Thank you for your feeling.
I have a good feeling Maggie's going to nail this test. I hope a lot of you are.
When are you just jinxed her?
No. Unjinxed. Okay, we're good. All right. Number 18.
Y equals absolute value.
Okay. If I want something to move left, I need to add 3 inside the absolute value. If I want to move it right, I need to subtract the number. Those were tough. The reason this one works, because if I work it out and write my 2 inequalities, I get that. This one works because if I write my 2 inequalities, I get that. Then they want me to work those 2 out to show why they work. I know. I'll show you why. Oh, contraire mon frère. Let's see why it doesn't. Brandon. It is an or. That's exactly why. Okay. So I have x is less than 3. Or if I multiply both sides by negative 1, I shouldn't be competing with anybody that's talking. So I get x is greater than negative 1. It's an or, so if I have a number line, 3 number lines, and I'm just going to sketch it for sake of time. Negative 1, 3, x is less than 3, or x is greater than negative 1. This goes back to the issues with units. The first part of this unit, this is part B. Where is one or the other graph? Everywhere. Not just in between.
Everywhere.
That's why 2 does not work. I hope you all understand that because it'll be on the test. Okay. Okay, next one. How do I make something wider? Oh, pay attention, you've been gone. By making this number less than 1. How do I make it upside down? That has to be negative. I'm just picking a fraction that's less than 1. I'm showing there's infinite number of right answers. If I want it moved to the right, I need to subtract something inside.
Yes, fine.
If I want it moved down, I have to subtract something on the outside.
Oh,
Shut.
That's it.
shut.
Alright, how many x-intercepts? Well, let's just take a look at a coordinate plane real fast. Is there any place you could see where it has 0 x-intercepts? Well, what about this guy right here?
A very small little baby.
There's 1, so that's 0. What about 1? What if it went like this?
Yeah, put it on the side.
Or like this? That's 1, 1, 1. Or it could have 2. 1, 2.
So I said 2.
Well, you got it wrong. Okay, and then you'd explain that it depends where it is, and yes. Now, sure.
So are you implying that the graph doesn't go on stereo? Is that what you're saying? Wait, is that what you're saying, Don?
What's the question again?
Because the graph doesn't let you go on stereo, too. Otherwise, it
Jimmy,
would be...
stop trying to be a smart aleck. You're not working.
I'm not. Otherwise, it would be... Oh, wait.
Yeah, we already
Wait,
knew
no,
that.
right, like, on
We
the
know your
one,
mom before you open your mouth.
on the one that you said, like, the one that you said is 0, so if the graph kept going, that would have X, or, wait,
There's
no.
only one x-intercept on
Sorry,
the
I was
plane.
thinking of the y-intercept, never mind.
Yeah, there will be a y.
Yeah.
All right. So the bonus. As soon as you're quiet, we'll go over the bonus.
Yeah.
So could you say whether that one exists, and where the graph is located on?
And then maybe show it. Yeah. Show the instance of 0, 1, 2. So this is how I started off with this one. I knew that my optimal reading needs to be between 180 and 200, right? So it has to be 10 more or 10 less than 190. That's what I knew my answer had to be. So how do I get that answer? Well, I know my inequality has to be less than or equal because it's an and. Okay? And what do I know, and what's going to give me that answer? Well, what if I go x minus 190 is less than or equal to 10?
Where'd you get 180 and 200?
Okay, what do I get when what's within 10 mean?
Oh, so you could subtract 10 less than 10 more.
Remember, English does play a role in math.
I think that's not fun.
Okay. So, watch. So you can try this, and you guys know how to solve these. So let's see if this works. Is x minus 190 less than or equal to 10? And does x minus 190 greater than or equal to negative 10 give me my answers that I want? Here, if I add 190, I get x is less than or equal to 200. Yep. Here, if I add 190, I get x is greater than or equal to 180. So that is the right inequality.
Flag. Alright.
Absolute value inequality to get that solution. So for the rest of the period, we're going to practice. I have some practice problems for you. I'll give you some graph paper. Tonight, you can watch this on Google Class or YouTube. I'll have the link in Google Classroom if you want to go back through at your own pace.
And that's a wrap.
Thanks for watching.
Wait! Woo! Oh, here. That was a close one.
Two videos!